Good morning and welcome to Tuesday of week 6 of your Physics 5 a day. And after a long first day of medical yesterday, you'll be pleased to know that the second day of medical is much easier. It's mostly ultrasound, and so here we go. As you remember from GCSE, ultrasound waves are sound waves with a frequency of more than 20,000 Hertz. And that means that humans can't hear them. But like all sound waves, they're longitudinal. And so when this speaker here, for example, makes a sound wave, it does it by moving a diaphragm backwards and forwards. This pushes air particles, which oscillate backwards and forwards, knocking the next particles on, and so on and so on. And that's how the pressure wave travels through the air to your ear. Now, whereas a loudspeaker will make sound waves that we can hear, to make an ultrasound wave, we use something called a transducer. And whatever it is that's moving backwards and forwards in the transducer needs to be doing it very quickly to make a sound wave with this high frequency. And the thing that's doing it, the thing that's moving backwards and forwards very quickly, is a piezoelectric crystal. And the thing that's special about a piezoelectric crystal is that if you put a voltage across it, it will bend. And if you were to switch the voltage around, it would bend the other way. So instead of having a direct current, if you instead have an alternating current there, you get an alternating voltage and you're able to make your piezoelectric crystal bend backwards and forwards very, very quickly. And this is how you're going to make your ultrasound wave. So I'm just going to draw an arrow. Here's our ultrasound wave coming out from the transducer. But the other thing about piezoelectric crystals is that if you bend them, you'll get a voltage across the crystal. And if you bend it the other way, you get a negative voltage. And this is called the piezoelectric effect. If you bend the crystal, you'll generate a voltage across it. But it also works in reverse. If you put a voltage across it, then the crystal will bend. And what that means is that if you turn on the alternating voltage for a short amount of time, you'll generate a pulse of ultrasound. And then whatever it hits, it's going to reflect back. And then when it hits the piezoelectric crystal again in the transducer, it's going to make it bend and you'll generate a voltage. So the transducer both emits the ultrasound wave and receives it. Or rather, I should say, receives the reflection.